Unit 6, pages 195 to 197, the fundamental theorem of calculus, particle motion, and average value. 3 things to always keep in mind. First being the integral from a to b of v of t dt equals p of b minus p of a, where v of t represents velocity and p of t represents position. So this is just a restatement of talk. Second thing to keep in mind is that the integral from a to b of v of t dt is equal to the net distance the particle travels on the interval from t equals a to t equals b. If v of t is greater than 0 on the interval from a to b, then it also represents the total distance. Okay, so this is important. V of t greater than 0 is equal to the total distance as well. So this is basically saying net distance, which means point A directly to point B, right? It's a straight shot from point A to point B. That's what net distance is calculating. And the third thing to keep in mind is that the integral from a to b of the absolute value of v of t dt is equal to the total distance the particle travels on the interval from a to b, whether or not v of t is greater than 0. To be safe, always do this integral when asked to find total distance when given velocity. Okay, so total distance means that we're calculating from point A to point B with all changes in direction, right? So absolute value of v of t is taking into account all possible changes in direction that could apply. So we're going to do a few problems, keeping those things in mind. The velocity of a particle that is moving along the x-axis is given by the function v of t equals 3t squared plus 6. This is a non-calculated problem. If the position of the particle at t equals 4 is equal to 72, what is the position when t equals 2? So we know that our time is 4 and 2. So our integral is going from 2 to 4 of 3t squared plus 6 dt, and that'll be equal to our position at 4 minus our position at 2. So on the left side here, I'm going to take the antiderivative, and we know that to do that, we're going to add 1 to the exponents and divide our coefficient by our new exponent. So 3 over 3 is going to be 1, and 6 over 1 is going to be 6. And we're integrating this from 2 to 4. We know P of 4 is 72, so we have 72 minus P of 2. So now on the left side, I'm going to apply Fatak once again. So we have f of b, which is 4, so we have 4 cubed plus 6 times 4 minus 2 cubed plus 6 times 2 equals 72 minus P of 2. Keeping in mind that we're looking for P of 2. So we have 88 minus 20 equals 72 minus P of 2. 68 to 72 minus P of 2. So P of 2 is equal to 4. Okay. For the second problem, part B, we want to know the total distance of the particle travels on the interval from t equals 0 to t equals 7. Okay, so total distance, we need the absolute value of v of t. Or we can check to see if v of t is greater than 0 on our interval. So since we're on the interval from 0 to 7, and we know that v of t is 3t squared 6, all values between 0 and 7 are going to be positive. Okay. If we look at this, there is no value that will be negative, because if we try to solve this for 0, and -6 equals 3t squared, -2 equals t squared. T squared can never equal -2 because you can't take the square root of -2. So v of t will never equal 0. So it will always be positive because it will never change direction. Okay, so that means that v of t is greater than 0 on the interval from 0 to 7. Therefore, total distance is the same as net distance. So in order to find the net distance, we want to go from 0 to 7 of our function, which is 3t squared plus 6 dt. So we'll find the antiderivative of this, which we've already done part A. So we have t cubed plus 6t from 0 to 7. And using photok, we know that that's 7 cubed plus 6 times 7 minus 0 cubed plus 6 times 0. This whole section is 0. So we have 385 is the total distance the particle travels on the interval from 0 to 7. Okay. So moving on to the next page. Velocity of a particle that is moving along the x-axis is given by the function v of t equals 0.5 e to the t times t minus 2 cubed. This is a calculator problem. If the position of the function at t equals 1.5 is 2.551, what is the position when t equals 3.5? So first thing I want to set up is the integration that I'm going to need to do. So I know that I'm going from 1.5 to 3.5, so those are my limits of integration. And my function is 0.5 e to the t minus 2 cubed dt. And using photok, we know that that means I'm going to have p of 3.5, right, since this is velocity. Using photok, I'm going to have position at 3.5 minus position at 1.5. And then this is where the calculator comes in, because I can plug this into a calculator. And I'll get 15.919 is equal to e of 3.5, which is what I'm looking for, minus, and we know p of 1.5 is 2.551. So p of 3.5 equal to 18.470. Okay. Part B, we want to know what the total distance of the object travels on the interval from 1 to 5. So we have our limits of integration. We want 1 to 5. Total distance, which means we need the absolute value of our function, 0.5 e to the t minus 2 cubed dt. And since this is a calculator problem, just plug this into the calculator and figure out what your answer will be. Graph of the velocity measured in feet per second of the particle moving from along the x-axis is pictured below. Position P of t of the particle at t equals 8 is 12. Use the graph of v of t to answer the questions that follow. So we know that t of 8 is equal to 12 for position. So P of 8 equals 12. That is a point of information that we know. We want to know what the position of the particle is at t equals 3. So to do that, we have a position at 8, right? And we need a position at 3. So we know our limits of integration are from 3 to 8 v of t dt. Right? And using Fatak, that means that we're going to have p of 8 minus p of 3. And p of 3 is what we're looking for. So if we look at this graph, here's 3, here's 8. Since we don't have a function for this graph, we're going to need to find the area between the curve and the x-axis to identify the integral. So from 3 to 6, we have a trapezoid, right? Where the height of my trapezoid is here, and that's 5. And base 1 of my trapezoid goes from 3 to about 4. So this is 1. And base 2 of my trapezoid goes from 3 to 6, which is 3. So I know part of this is going to be 1/2 times 5 base 1 plus base 2. The second part of this integral is this triangle piece right here. And the area of a triangle is 1/2 base times height. Base is 2, height is -2. We're going to add to this 1/2 2 times -2. And that'll equal our p of 8, which we know is 12, minus our p of 3, which is what we're trying to find. So when you do this out, you get 10 minus 2 equals 12 minus p of 3. So -4 equals negative p of 3. So p of 3 is equal to 4p. And yes, we have units for this because we have units in the problem where it said velocity was feet per second. Okay. Part B asks for the acceleration when time is 5. Since we don't have a function here, we have to go back to what we know the derivative means, right? So acceleration is the derivative of velocity. And the derivative of velocity basically states the slope of velocity at a point t, right? So what we're looking for is the slope of this graph when we're at t equals 5. So a of 5 is equal to our slope at 5. So if we go to 5, 5 is on this line, and the slope of this line is I can't make a straight line. Slope of this line is about -5 over 2. Okay, so it's a rise of -5 because it's decreasing and a run of 2. So a of t is -5 over 2 feet per second squared since it's acceleration. Okay. Net distance. net distance from t of 0 to t of 10. So our net distance is just the definite integral from 0 to 10 of v of t dt. So what we're going to need to do is basically find the area under this curve all over the place. So we know the area of this space. We know the area of this space. And if you look closely, this is just this space over here. This trapezoid is half of the entire space above the x-axis, and this triangle is half of the entire space below the x-axis. So if we take the area of the trapezoid that we had, which was 10, and multiply it by 2, and then subtract to that the area of the triangle that we had, and times that by 2, then we'll get 20 minus 4, which is 16 feet. Another way you could do it is by finding the actual area of this entire upper piece and the area of the entire lower piece. Now this is where it gets a little bit tricky. Total distance, we want the absolute value. So we want the definite integral from 0 to 10 of the absolute value of v of t dt. Okay, so when we say that, that means that everything that's below the x-axis, so everything that was negative, we want to absolute value that and make it positive. So if we look closely, that means that we are taking all the negative stuff and bringing it above the x-axis. So this area of negative 4 is now going to become a positive 4. And this area, this whole trapezoid, was positive 20. So the total distance will be 20 plus 4 is equal to 24 feet. Okay, so total distance means that all the area that was once negative is now going to be positive when we add it all together. Okay. The table above shows values of velocity v of t in meters per second of a particle moving along the x-axis at selected values of time, seconds. What does the value of the definite integral from 0 to 18 v of t dt represent? I want you to complete part A, thinking back to the 3 things to always keep in mind from the beginning of this video. What does this definite integral represent in your own words? Using a left Riemann sum of 6 subintervals of equal length, estimate the value of the definite integral from 0 to 18 v of t dt and indicate units of measure. Okay, so the next few problems, B, C, D, and E, are all different Riemann sums that it's asking you to use on this table. I am not going to do every single one of these. I will do 2. I will do part B and part D, and then you are responsible for C and E. So for part B, we want to use the left Riemann sum on 6 subintervals of equal length. So if we look at my table, I want to go from 0 to 18. And I want 6 subintervals. So if I split this into 6 subintervals, I get 0 to 3, 3 to 6, 6 to 9, 9 to 12, sorry, 12 to 15, and 15 to 18. That's 6 subintervals. When I write this out, I'll get the definite integral from 0 to 18 of v of t dt equal to, since this is a left Riemann sum, I know that I'm using rectangles. So base times height. So the base from 0 to 3 is 3. The height is, since I'm on the left, I want v of 0 plus 3. From 3 to 6 is 3. And from the left, I want v of 3 plus, again, a base of 3, 6 to 9, times v of 6 plus 3 v of 9 plus 3 v of 12 plus 3 v of 15. When I plug in all those values, and I could pull out the 3 since it's being multiplied by 3 for each term, I'll have 3 times 2.3 plus 2.7 plus 2 plus 1.3 plus 1 plus 1.7. And that's equal to approximately 33 meters. Okay. Skipping part C so that you can do that on your own. Now we want to use a midpoint Riemann sum of 3 subintervals of equal length to estimate the value from 0 to 18 of v of t dt. Okay. So now we want 3 subintervals. So if we look closely, we can have 0 to 6 as one subinterval, 6 to 12 as another subinterval, and then lastly 12 to 18 as our third subinterval. So when we write this out, we want midpoint Riemann sum. So we want 0 to 18 v of t dt equal to, so now we have to look closely at what we have going on. So Riemann sum means we're using rectangles. So from 0 to 6, the base of that rectangle is 6. And the midpoint between 0 and 6 is 3. So 6 times v of 3 plus another 6 times v of 9 plus another 6 times v of 15. So we can pull out the 6 since it's being multiplied by every term. We have 6 times 2.7 plus 1.3 plus 7, which is equal to approximately 34.2 meters. And we'll skip over E so that you can do that problem on your own using trapezoidal sum. Now part F, we want to find the average acceleration of the particle from t equals 3 to t equals 9. For what value of t in the table is this average acceleration approximately equal to v prime of t? Explain your reasoning. Okay, so average acceleration is equal to v of 3 in our case, minus v of 9 over 3 minus 9. Plug that in, it's 2.7 minus 1.3 over negative 6 is equal to negative 0.233 meters per second squared. Now the question is this average acceleration approximately equal to v prime of t? So This problem gives us velocity in meters per second. We are led to assume that on the interval that we have from 3 to 9, our velocity equation is both continuous and differentiable. And if that is the case, then by MVT, we are guaranteed that a value exists between t equals 3 and t equals 9, such that v of t, or v prime of t, equal to v of 3 minus v of 9 over 3 minus 9. And the reason why we're led to believe that this is going to be continuous and differentiable is because we know that we are a particle moving along the x-axis and we're moving at a specific time, right? So time is in seconds. Time does not randomly stop, so there's no value of x that won't have a y value. So we're continuous. And since we're moving along the x-axis, we can assume that if we're continuous, then we will also be differentiable. So now, this is asking us for what value of t in the table is this average acceleration approximately equal to v prime of t. Well, if we look at our table, we know that there's some value between t of 3 and t of 9. The only value on our table between 3 and 9 is t equals 6. So in this table, that value is t equals 6. Okay, what I want you to do is complete parts C and E on your own using the right Riemann sum and the trapezoidal sum.